right. So when we do trig, there's more than three, but the three big ones, the three big ratios, understand what a ratio is as well. A ratio is a different way of writing a fraction. It's a comparison of two numbers. It's what we've been doing. Okay, when we take one corresponding set of sides, set it equal to another, it's two ratios set equal to each other. We set up a proportion. So that's why you're going to see all of these fractions right here. So when we start dealing with these ideas of trig, there are three most common ones. There's a handful of others, but the three big ones that we want to understand within right triangles. So again, all of these need to be a right triangle. So we can look at this guy right here and see our right angle. If it is a right angle, there are three ratios that were given names. Okay. One of those ratios is called the sine. All right. So when you see the sine of angle A, what that is telling you to do is come over here to angle A. So here is this angle right here. And what we would do is say that the sine of angle A is whatever the opposite side of angle A is. All right, and we'll set this up with our variables. So if this is angle A right here, the opposite side of angle A is what we called little a. That then gets divided, because again, a ratio is nothing more than the comparison of two numbers, often as a fraction, over the hypotenuse. That's the denominator in your ratio. So if this is our right triangle, the hypotenuse is always opposite of the right angle. So if this is our right angle, the side opposite of that, in this case, would be C. So the sine of angle A is just asking what is the ratio of the opposite side compared to the hypotenuse. And in this instance, it would be A over C. Okay. The second one, this is again, sine is our first one. The second really, really common trig identity is what's called the cosine, just a different way of comparing two numbers. So if I'm going to again do the cosine of angle A, that means I am again dealing with angle A. This is where you want to be a little more careful now. Cosine is the one you want to be careful of as we get this started. The other two are pretty simple. We want the adjacent side to this angle. So, well, if I look at this angle, we have two adjacent sides. This side is adjacent to this angle, and this side is adjacent to that angle. So there's really two adjacent sides. But if you look at what your denominator is, notice how the denominator says the hypotenuse. Which side is actually the hypotenuse, side B or side C? It's because both of these are adjacent. Side B is adjacent, C is adjacent. But one of these is the hypotenuse, and that would be which side? C. So if C is your hypotenuse, so that's going to be your denominator, then the adjacent side that we are looking for is the one that's not the hypotenuse. So the other side that's not the hypotenuse is B. So in this case, your adjacent side you would say is the B, and then over the hypotenuse, which is going to be C. Okay? So we have sine, we have cosine. Those are two of our three big ratios. The third one is what we call tangent. If I now want the tangent of this angle, the tangent is equivalent to the opposite side of that angle. So again, the opposite side of that angle is A. The adjacent side, again, keep this in mind now, there's two adjacent sides. The adjacent always refers to the non-hypotenuse. So the C is the hypotenuse. That means the adjacent side that we would want is still B. All right, so that would be the tangent of that angle. That is the ratio of angle A when we look at the opposite over the adjacent. Okay, off to the right here, one of the things that you will want to get memorized, a big takeaway for this week that you'll use as a junior, that you'll use as a senior, okay, in your actual trig class. The most common way to get this memorized, a little memorization trick to do this, is this guy. So write this down. And anybody who's had math too, anybody who is a senior right now in trig or calc, all of them will know this little acronym for these three words, okay? And it's SOHCAHTOA. So the SO and then CA and then TOA is just giving you a little acronym for what we are trying to find up here. So when we talk about this one here, which you would just say is SO, what that means is the sine. So notice this S, you can see me highlighting over here, the sine of an angle, and then see how you have the O over the H, is the opposite over the hypotenuse. So that's where the SOH comes from. We find sine by doing opposite over hypotenuse. If I'm going to do the cosine, Come down here to where we have cosine, that's the C. Notice how you have an A and an H because you're going to do the adjacent over the hypotenuse. All right, that's where the ka in the between comes from. And then third and final one is the TOA, and that is for the tangent for your T. And the T is the opposite side over the adjacent side. So TOA means the tangent is opposite over adjacent. Okay. Anybody who's had trig before will know this. You will remember that. You'll want to use that over the next handful of years. So that's the relationship for sine, cosine, and then tangent. Okay. All right. So as we go to this next one, I want you to find these values here. All right. So if we understand what we're looking for, let me write this above so it's all on my screen. You have it on your paper you could reference. But here's our little acronyms for each of these. So if I look at letter A and I want the cosine of angle A, that means we are looking at this one right here. The cosine is the adjacent side over the hypotenuse, and we're going to do that in this case with angle A. So angle A is this guy right here. Okay, so if it's the cosine, again, I'll write it in words first. It's the adjacent side, that's the A part, over the hypotenuse, that's where this H comes from. So if this is my angle, we have two adjacent sides. This side is adjacent, this side is adjacent, but only one of those is the non-hypotenuse. The non-hypotenuse is the 12. The C is the hypotenuse, so the adjacent side we would say is a 12. The hypotenuse is always the opposite of the right angle. We are not going to put a C right here because we have a way to solve this. We just reviewed this a little bit from that homework yesterday. So we do now want to go ahead and figure out what C would be. This is a right triangle. If I know two of the three sides, as we reviewed a little bit with the homework, we can do the Pythagorean theorem to always figure out that third side. That's kind of the very first right triangle trig idea, is the Pythagorean theorem. The hypotenuse is what we are looking for, is that C. And then the two legs are 5 and 12. So we would do 5 squared plus 12 squared equals C squared. Clean those up. So 5 squared is 25 plus 12 squared, which is 144. And then that would equal C squared. Add those to get 169. Unless you're really, really good with your perfect squares, this doesn't look promising. However, this is a nice perfect square. Does anybody actually know what that is? Good, 13. All right, so C ends up being a 13. So now we can come over here. If I looked at angle A and I wanted the adjacent side over the hypotenuse, we now know that the hypotenuse is 13. Okay? So what that's telling is if I'm at angle A, I know the side that's adjacent to me has a length of 12, and the side that's the hypotenuse has a length of 13. Okay? Now, so far we've only dealt with angle A. Both of these triangles are kind of oriented in the same way, and we were always dealing with this angle. We can do this for angle B as well. So now I want you to look at angle B. So now we're going to come up here. So now this is where we're going to base everything off of, is up here at angle B. We're now going to do the sine of the angle. So we are now dealing with this guy right here. So the sine, this is the so part, the sine is the opposite side over the hypotenuse. So in this case, we want the opposite over the hypotenuse. But we're going to do this now with angle B. So if you look at angle B up here, I want the side that is opposite of angle B. So if this is angle B, the opposite side of angle B is the 12. So notice how 12 is the adjacent side for angle A, but it is the opposite side for angle B. Okay, so that's why we always got to know what angle we are dealing with. The hypotenuse would never change. The hypotenuse is still that 13, and then that is your answer. All right. Okay, real quick, try letter C. People tend to get this fairly nicely and quickly, hopefully. This is now the tangent of angle B. So you're going to be looking at angle B. Tangent is this TOA part, so understand what the O and the A would mean, and see if we can identify what the tangent of angle B would equal. Hello. Either way. Who's that? Nora's here. Okay, I just need to steer the phone. Okay. Good luck, Nora. See you on the other side. All right, let's see what we have here. There's not a lot of work, all right, at least not yet. You're just looking at it and telling me what these numbers are. When we see the tangent, the t, that's why we're going to look up here. And then since it's TOA, that means we want the opposite over the adjacent. So we're wanting the opposite to be the numerator, the adjacent to be your denominator for angle B. All right, so if this is angle B, Mo, what side was opposite of angle B? Good. The 12 is the side that's opposite of angle B. The adjacent side is the one to be careful of because angle B has two adjacent sides. This is adjacent and this is adjacent, but one of them is the hypotenuse. So we want the one that's not the hypotenuse. So Assad, that would be what? 12. So here's angle B, right? So this side is adjacent. This side is adjacent. So it's got to be 13 or 5. However, which one of these is the hypotenuse, the 13 or the 5? 13. Good. So the other one has to be the one that we call the adjacent. All right. So if you got 12 over 5, then you had that correct. Okay. Following that. Okay. Then real quick, I'll give you a minute here. You're going to do each angle. A, we want the sine, cosine, and tangent of A. And then you're going to do the sine, cosine, and tangent of B. All three values are given to you, so we don't need to do any Pythagorean theorem. So take a minute, see if we can set this up. Again, you're dealing with this idea here. You can see it on your paper. I'll write it, so when we reference it, we'll be able to see it. But the little phrase here, SOHCAHTOA. All right, so sine, cosine, tangent, and then the letters that follow tell you what's on top over whatever's on the bottom. All right, so see if we can get those 6. Once you have them, you can also practice, because I will want you to, if possible, reduce those fractions. So that would be something you can use your calculator to see if you know how to do it in a calculator, do it in your head. But all those fractions will reduce a little bit. Yeah. So you're going to go to angle B. Just like you would have done cosine here. Just 6 cosine A. So cosine is going to be a fraction. It means you want the adjacent over the hypotenuse. And we want that for angle A. So this is angle A right here. This is your adjacent side. Yeah, 8. Okay, so if you understand now, then now you're going to go to B and do the exact same thing. So this is angle B side. We'll say it's the adjacent side. So you say all right, let's see where we're at here. Jake, what'd you get for the sine of angle A? Good. So sine is the opposite side over the hypotenuse. So here is angle A. The opposite side is 6. The hypotenuse is 10. So we would have 6 over 10. I would want you to reduce these when the time comes, but 6 over 10 right now, that's the big picture idea. I want to make sure we understood. But if we reduce that, it reduces down to be 3/5. Okay. All right, cosine of angle A. Tomas, what'd you get for the cosine of angle A? Good. 8 over a 10. Cosine is the adjacent side of angle A. That's 8. And the hypotenuse, which is the 10. All right, so 8 over 10. If we reduce that down, we would get 4/5. All right, tangent of angle A. Ella, what'd you get? Good. Tangent is the opposite side. We're using this little acronym here. The opposite side is the 6. The adjacent side to angle A is 8. So we would get 6 over 8. All right, and then she did reduce that for us down to 3/4. When we go to B, it's all the same ideas in terms of opposites, adjacents, hypotenuses, except now we're just doing it with a different angle. So now if I come up here to angle B, all right, Julia, what'd you get for the sine of angle B? Good. Well, what was the initial numbers? Good. 8 over a 10. Sine is the opposite over the hypotenuse. Here's your opposite side. Your hypotenuse is a 10. So 8 over 10, and then she had given us the reduced version of 4/5. All right. All right, cosine of angle B. Joel, what'd you get? Good. B has 2 adjacent sides, but one of them is the hypotenuse. So the adjacent side is the one that is not the hypotenuse. So that's why he has the 6. And then we're putting that over the hypotenuse of 10. And then that would reduce down to be 3/5. All right. And then Mo, what'd you get for the tangent of angle B?
8 over 4.
Good. Opposite side of angle B is 8. And then the adjacent side we just said is 6. And then that would reduce down to be 4/3. All right. So walk out here today understanding those 6 problems. And for the most part, you're walking out here knowing what we want you to understand, okay? And understanding these 3 little acronyms here. All right. When we go to number 3 here, so here's what I kind of want you to understand about this. This is an isosceles triangle. So we can go ahead and mark that. We're kind of marking it anyway with 2 17s. And then I want you, in this case, it says find the sine of angle C. So what that would mean is, here is angle C. Try to do that for me. See what you think. All right. So I was kind of watching. People started to write stuff, picked up their pencil. I could see the wheels turning a little bit. You should be stumped to some element here, correct? Hopefully. Because if we understood the whole SOHCAHTOA idea, which we definitely want to understand that, we are dealing with this guy here. So we don't have to worry about those two, but we are looking for the sine of angle C. So we would want the opposite side of C. So this, most people right away look at this and like, oh yeah, that's 17. So that's good. And this is usually when the pencils stop and I can see people start to think a little bit. Because if I want the hypotenuse right here, what do we think for that hypotenuse? It's a trick question, Matt. You going to give me the right trick answer? What is it? Not quite. And it's a trick question. So we were all stumped a little bit on this. Isn't a hypotenuse defined as the side that is opposite of the right angle? So if we look at this guy right here, just to the eye test, and plus it's not marked, does this appear to be a 90-degree angle? No, and I would need to mark that for you to even assume that it would be anyway. Is this a 90-degree angle? No. All right. So the reason I want to now give you this and make sure you understand these ideas, things like the Pythagorean theorem and things like sine, cosine, and tangent are all right triangle trig terms. If we do not have a right triangle, then we cannot use the Pythagorean theorem. You cannot use sine, cosine, and tangent. Okay, what we do in geometry now in math 2 is right triangle trig only. If this is not a right triangle, we cannot do this problem. All right, so this you're kind of stuck because basically it's not a right triangle. And then you could see what your dilemma was if you tried to do this. You would have hopefully have had a hard time finding the hypotenuse because there was no 90-degree angle to look at, okay? Okay, so basically you can't do that problem. Okay, so real quick, we'll get done one or two of these. You've got the gist of this, but this will be a little more practice. It says, the following is a list of conjectures. Conjectures are educated guesses, largely, in layman's terms, made by students about right triangles and trigonometric relationships. So we are back to a right angle, so now we can basically do those four things, Pythagorean theorem, and then sine, cosine, tangent. And it says, for each, state whether you think that the guess is true or false, and then justify this by showing your work. All right? So if I had you find these two, so real quick, you should be able to do these two. Find the cosine of angle A, find the sine of angle A, and then pretty simple, you'll be able to identify if they are or are not equal to each other. If they're not, you're going to say that's a false statement. If it's true, you're going to say that that is a true statement. Okay, so if I ask you for the cosine of angle A, so we're going to look at this angle for both. Here is angle A. All right, so if I ask you for the cosine of that angle, Omar, what did you think the cosine of angle A was? You're good. 4/5. The cosine is the adjacent side of 4 over the hypotenuse of 5. All right, and then we just go to the other side and see if the sine of angle A gives you the exact same thing. All right, so the sine is the opposite over the hypotenuse. So when I now do the opposites over this hypotenuse, are these going to be equal to each other? No. So this one would be false. All right. So the sine and cosine of the exact same angle, probably not going to be the same, at least not all the time. All right, go to letter B though. So jump down, or not letter B, number 4. So come down to number 4. Answer number 4. We still, in number 1, we did cosine equal to a sine, but it was of the same angle. This is now, is the cosine of angle A equivalent to the sine of angle B? So do number 4 real quick. Make this a little smaller. All right, so now this guy, Jada. What'd you get for the cosine of angle A, Jada? Good. So angle A is this blue one. The adjacent side is 4. The hypotenuse is 5, so she said 4/5. Now we go to the other angle, angle B, and I want the sine of angle B. So Ben, what do you think the sine of angle B would be? Good. Opposite of angle B is 4. The hypotenuse is 5. So was this true? Yeah. So that will be a true statement. Okay. The sine and cosine are equal to each other if we're doing the other two angles, the opposite angles of each other. Okay. All right. Last one I want to get to, because this one you will definitely, well, let's do it first. See if the tangent of angle A, so number 2, is equivalent to the sine of A divided by cosine of angle A. So see if that is true or not. If you're not good with fractions, you may need a calculator to kind of determine if they're ultimately equal. Okay, good one to wrap up with because it's all 3 of them. You're going to have to do one sine, you're going to have to do one cosine, you're going to have to do one tangent. It's the 3 acronyms that we want to walk out of here knowing. So if the first one is the tangent, that's this guy, the TOA idea. We're going to do all of these with angle A, which is this blue one. So if I ask you for the tangent of angle A, Seaham, what'd you put?
80. I put 3/4.
Good. Opposite side is 3. The adjacent side is 4. So the tangent of angle A is 3/4. We want to now see if we could find the sine value of the cosine, divide them, and get a 3/4. Okay? So if I now do the sine of angle A, we're now using this guy. So now I want the opposite side over the hypotenuse. So Monica, what would be the sine of this angle? Good. 3/5 is that numerator, opposite over hypotenuse. And then last but not least is the cosine of angle A. So now we're going to use this guy right here. The cosine of angle A. Omar is what? Good. 4/5. And this is where, depending on how good you are with fractions, if you're not, throw this into your calculator. Is 3/5 divided by 4/5 equivalent to 3/4? It is. Okay? So this is a true statement. Basically, these denominators cancel. You end up with 3/4. This is a big one that you will use a lot. Tangent is the same as sine over cosine. Okay? All right. This, you do have a little bit to do tonight. Just plugging in the calculator. Yeah. Oh yeah. I'm gonna do quick to